G'day guys, Mr. Bennett here. Today we're going to be looking at a moving coil loudspeaker, which is obviously an application of current carrying wires and magnetic fields. The first thing is you're going to have to look at my crappy diagram of a speaker, but you'll see in your book there's some nice diagrams representing this. The key thing is we have our cone bit here, we have our permanent magnet that we have shown here, and we have our voice coil. So a voice coil is made up of a very thin wire, and I'll show you one of those in class as well. So the main thing here to understand that obviously field lines go from north to south. So our field lines will be going in this direction here on that side, and they go in this direction here on this side. They go from north to south. Okay, so we have to think about what's actually happening here. I might just enlarge that over on the side over here. So we've got our current carrying wire. Imagine that. And we've got our field lines going in this direction here. A uniform a magnetic field. Then what we have to do is think about our right hand palm rule. So on this side over here, the crosses mean that the current goes into the page. Our field lines are going to obviously going to the left, which means that my palm would be pushing up. So that would mean that there would be a force that's actually pushing up this way. We do the same thing with the other current carrying wires, and these ones here are dots, because that means the current's coming out of the page there, and our field lines are going in this direction over here. Alright, so we did the same thing there. The field lines coming out of the page, that means my palm will still be pushing up. And that's a good thing, because that means that our voice coil with this setup is going to be pushing up that way there. Now, how the speaker works is you can change the direction of the current inside the voice coil quite quickly. Now, the current moves pretty well at the speed of light. So we can get sounds now, obviously for us, I mean, we want to go up to about 20,000 hertz. That's about our range of hearing. So every time our cone gets pushed up like that, what happens, it squashes all the air particles together. Right, as we know about sound, produces a compression wave. Okay, and then what's going to happen is we're going to change the direction of the current in the voice coil. So obviously if I now do this and I change that to be there, the magnetic field's not going to change the direction, but if we change the direction of the current, that means that instead of being pushed up now, it's going to be pushed this way. Alright? And so our force. So our particular voice coil, voice cone over here, is going to fluctuate between going up and down, and the way we change the frequency there is changing the direction of the current inside the actual the voice coil itself. So we have an alternating current through there, and that will produce a certain frequency sound in the cone in the speaker. And that's pretty well simply how a moving coil loudspeaker works. Now, speaker technology has certainly changed a lot over the last few years, and that might even be quite a good application thing for you to have a look at, is looking at the technology behind, implications for humanity, is how sort of speakers work and the new technology that's involved with that. So certainly, music is a very important part of most people's lives, and obviously the technology behind that's a really important development, and something that if you're looking at any of these companies involved in that are developing new technologies all the time. So in terms of what you have to understand, you have to better explain the process of the voice coil. So the key steps that you need to look at here is, first of all, okay, showing the physics behind the current carrying wire, in a magnetic field. So that's the first thing that you need to do, is explain that. The second thing you need to explain is the frequency is basically resulted as a result of changing the direction of the current. So you might call that an alternating current. Okay, so that's the key stuff that you need to then talk about there. And the third thing I'd be talking about here is, obviously sound is a compression wave. Right, so you need to make sure that you've got a sort of dialogue that you need to talk about with that. A key thing is really the diagram. I think that really helps you explain what's going on. So you need to work on representing your diagram properly. So make sure you certainly know this. There'll definitely be a question like this in the test. You can always assume there'll be one of these type of questions in the exam as well.